Alrighty, so this one is on perpendicular bisectors. So perpendicular bisector, hence the name. Okay, so perpendicular, and then bisector is cut in half. Okay, so where is it located on our triangle? It is perpendicular to a side and bisects that same side. So now let's take a look at this picture here. So I have this picture here. If we take a look at this line, let's go NQ. So this line NQ. You will see here that if I extend this line further, it does not intersect the vertex. A perpendicular bisector will not intersect does not have to, let me rephrase that, does not have to intersect the vertex. What it needs, all that it needs is perpendicular and bisecting the side. Okay, so you'll see here that we have AN and NB, sorry, CN is congruent to BN, and angle let me rephrase that, QNB is right. Okay, so you'll see here that's what you get. So for a perpendicular bisector, that is what you get with the lines. Now I'm going to take a look at the other lines. So we have here MQ. So you take a look here at MQ, you get a right angle, and then these two segments are congruent. So it is bisected, okay, bisected. Now we'll see here that the other line does not have one, so I'm going to do a rough sketch. Hopefully it looks kind of like a bisector. So here, there's no D here, so let's put a D. So I'm going to extend this line. And we'll see here that you will get the two AD and DC congruent, and you'll get the right angle. They're all going to intersect at the same exact point, okay? So when they intersect at the same point, that is called the point of concurrency. Specifically, it is called the circumcenter. So just like the altitude, an acute triangle is on the inside, obtuse it's on the outside, and a right triangle is on the hypotenuse at the midpoint. So the obtuse triangle is similar to the altitude. So these ones are similar to the altitude. If I were to draw a right triangle here, and I were to draw the perpendicular bisectors, we have here, let's say this is a perp bisector. Okay, we have here, let's say this looks pretty accurate. And then I'll draw one here. Okay, so all of these red lines here are perp bisectors. As you'll see, they intersect here on the hypotenuse. So on the hypotenuse at the midpoint. So this is where they'll intersect. Now, a couple of things. The circumcenter is equal to the distance from each vertex. So the circumcenter is equal to each distance from the vertex. So I'm going to go ahead and I'm going to erase all this stuff here. Okay, I'm going to erase all this stuff here. Now, we have here this, let me make this wider. Okay, so this is a perpendicular bisector. This here is also a perpendicular bisector. And if I were to have this one drawn, this as well, rough sketch, bear with me, is a perpendicular bisector. Now, the other segments from the circumcenter to the vertex, here, CQ, QB, and I'm going to draw AQ. Those are all congruent. Those are all congruent. They're going to have the same exact distance, okay? Next, you have, the right angles are formed and the midpoint. Okay, so midpoint gives you two congruent segments. So let's do examples here. So I'm going to erase these lines here. I'm going to leave my red lines, though, just for example. So taking a look, we have, going forward, if we knew AM was 10, we knew MB would be 10. If QMB is 90 degrees, because the right angle, we know AMQ is also 90 degrees. Okay? If I know that QB is 5, has a length of 5, AQ has a length of 5, CQ has a length of 5. If I knew that CB CB was, let's say, 30. Oh, well, then we know that CN would be 15 and NB would be 15. Okay, because those two segments are congruent. All right, and that's it for perpendicular bisector.